In December 2022, the James Webb Space Telescope peered into the cosmos and captured images that made astronomers pause, images that defied decades of cosmological models, images that whispered a tantalizing, almost unsettling truth. The universe may be far stranger than we ever imagined. These were galaxies appearing when the universe was only a few 100 million years old, fully formed, massive, and seemingly mature in ways that should have been impossible. According to the standard model of cosmic evolution, such galaxies should not exist yet. They should be chaotic clouds, slowly coalescing over billions of years. And yet, here they were, luminous and distinct, shining across space and time as if the rules of formation had been rewritten. To gaze upon them is to confront the fragility of our understanding and the audacity of the cosmos itself. If the idea that the universe may be bending the rules of physics intrigues you, subscribing allows you to continue exploring these anomalies as astronomers push the limits of observation and imagination. The universe, as we have long understood it, followed a narrative of gradual growth. Following the Big Bang, matter cooled, coalesced, and over hundreds of millions of years began to form the first stars and proto-galaxies. Gravity drew gas and dust into larger structures, merging them over time into the spirals and ellipticals we see today. It was a slow, patient process, one that allowed astronomers to calculate timelines, estimate galaxy ages, and construct a model of cosmic history. But the James Webb Space Telescope's observations disrupt that narrative entirely. These early galaxies are too massive, too structured, and too luminous to have formed in such a short period. They appear almost fully grown in the infancy of the cosmos, a defiance of the models that have guided cosmology for decades. Some of these galaxies possess stellar masses comparable to our Milky Way, yet they existed less than 500 million years after the Big Bang. To put that into perspective, the universe itself was barely 3% of its current age, a newborn in cosmic terms. Stars should have been forming slowly, gas clouds should have been clumping unevenly, and any structure should have been fragile. Yet Webb reveals galaxies that are already mature, organized, and glowing with the light of billions of stars. Their existence forces us to ask uncomfortable questions. Have we underestimated the efficiency of star formation? Are our models of dark matter flawed? Or is there an entirely new process at play that accelerates galaxy formation in ways we cannot yet comprehend? The answers remain uncertain, but the implications are staggering. And these galaxies are not isolated anomalies. Webb's unprecedented sensitivity allows it to probe deep into the universe, detecting dozens of such unexpected structures, hinting that the early cosmos may have been more dynamic, more productive, and far more complex than we ever predicted. Each discovery compounds the mystery, creating a cascade of questions. How many other galaxies formed early, unseen, waiting for our instruments to reveal them? Could there be mechanisms of star formation, black hole growth, or gas dynamics that we have entirely overlooked? Or perhaps the very framework of the Big Bang timeline itself requires reconsideration. In confronting these possibilities, we are reminded of the humility required in science. The universe is far more intricate than our theories, and each observation is both a revelation and a challenge. The magnitude of these discoveries extends beyond pure astrophysics. If the early universe was capable of producing massive, mature galaxies so quickly, it reshapes our understanding of cosmic evolution, the formation of elements, and the timeline of structure formation. These galaxies may contain clues to the first generations of stars, the behavior of dark matter, and the seeds of supermassive black holes. They are laboratories from the dawn of time, offering a glimpse into processes that occurred when the cosmos was still in its formative years. The implications ripple across physics, cosmology, and even philosophy. What does it mean to see structures that should not exist in a universe we thought we understood? Each discovery forces us to expand our imagination, to consider that the cosmos may operate according to principles we have yet to grasp. And yet, amid the shock and wonder, there is a subtle, thrilling possibility. These galaxies are invitations, calling us to explore deeper, to question boldly, and to follow the evidence wherever it leads. Perhaps they hint at physics we have yet to discover, at new mechanisms of star formation, or at unforeseen interactions between dark matter and ordinary matter. Perhaps they are reminders that the universe is far more creative, more efficient, and more astonishing than our models can predict. To witness these galaxies is to witness the universe's audacity, a defiance of expectation, a challenge to human understanding. If this glimpse of cosmic rebellion excites you, subscribing ensures you are part of the ongoing journey, following each revelation as the James Webb Space Telescope and future instruments uncover more of the unexpected. The cinematic sweep of these galaxies is breathtaking. Faint smudges of light billions of years old, captured with clarity and precision, shining across unimaginable distances, each one a testament to the cosmos' capacity for complexity and surprise. They are reminders that the universe is not a passive stage for human observation, but an active, dynamic, and sometimes shocking actor, capable of producing outcomes that challenge every assumption we hold. The galaxies that shouldn't exist become symbols of curiosity, pushing us to reconsider what we know, to embrace uncertainty, and to marvel at the richness of a cosmos that refuses to be simplified. Even as we grapple with these questions, the James Webb Space Telescope continues to scan deeper, sharper, and more expansively than ever before, promising further surprises, more galaxies that defy expectation, and perhaps new rules of formation we cannot yet imagine. The telescope reminds us that knowledge is provisional, that every model is an approximation, and that the universe, in all its immensity, has the power to astonish us repeatedly. And so, as we look at the light from galaxies that shouldn't exist, we are invited into a grand experiment of observation and imagination, following the cosmos into realms we once thought impossible. Subscribing allows you to remain part of this adventure, witnessing each new discovery as it reshapes our understanding of the universe and our place within it. The discovery of these galaxies does more than shock our understanding. It demands a reckoning with the very foundations of cosmology. Our current models of the universe, built over decades from observations of the cosmic microwave background, galaxy surveys, and theoretical physics, rely on a timeline that predicts gradual, orderly formation. The early universe, according to these models, should have been a chaotic, relatively empty expanse, where stars formed slowly and galaxies emerged over hundreds of millions of years. But Webb shows us something entirely different, massive luminous galaxies emerging almost fully formed when the universe was barely a fraction of its current age. This contradiction forces a profound question. Have we misunderstood the efficiency of cosmic evolution, or does the universe contain hidden mechanisms that accelerate creation in ways we have yet to comprehend? One possible explanation is that star formation in the early universe was far more efficient than previously imagined. Perhaps the first generations of stars, born in rapid bursts, seeded their surroundings with heavy elements, facilitating the swift formation of massive galaxies. The universe may have had pockets of extreme density, where gravitational collapse proceeded at a speed and scale that defies standard models. If this is true, then our timeline of galaxy formation requires revision, compressing what we believed were billions of years of gradual growth into mere hundreds of millions. And yet, even this explanation strains credulity. The sheer size, structure, and luminosity of these galaxies suggest processes far beyond simple star formation. They hint at physics that may be operating differently under the conditions of the early cosmos. Another avenue of speculation involves dark matter, the invisible scaffolding that shapes the cosmos. Dark matter halos are believed to provide the gravitational framework in which galaxies form, drawing gas and dust into dense regions where stars ignite. Could it be that in the early universe, dark matter behaved differently, clumping more efficiently, or interacting with ordinary matter in unexpected ways? Such a mechanism might accelerate galaxy formation, but it would also challenge the assumptions underlying decades of cosmological models. If dark matter itself operates differently in the young universe, it suggests that what we thought were universal constants may in fact be local rules, dependent on time, scale, or environmental conditions, revelation with staggering implications for our understanding of physics. The anomalies extend beyond mere formation rates. Some of these early galaxies exhibit shapes and structures that mirror those of mature galaxies observed today. Spirals, dense cores, and organized disks that should take billions of years to develop. How could such order emerge in the infancy of the universe? Could there be processes, yet undiscovered, that accelerate galactic organization, or are we witnessing evidence of a cosmos more self-organizing than our theories allow? Each galaxy captured by Webb becomes a puzzle piece, hinting at laws of nature that remain hidden, mechanisms that may rewrite our conception of cosmic evolution entirely. These observations also raise existential questions about the predictability of the universe. If galaxies formed more rapidly and efficiently than our models suggest, what does this imply about the broader cosmic narrative? Are we underestimating the universe's capacity for rapid, large-scale organization? Might other phenomena, like the growth of supermassive black holes or the emergence of early star clusters, also be accelerating beyond expectations? The implications ripple through astronomy, physics, and philosophy, forcing us to confront the possibility that the cosmos is far more unpredictable, more creative, and more astonishing than we have imagined. Subscribing allows you to follow this unfolding mystery, as each new Webb observation challenges our assumptions and reveals more of the universe's hidden genius. Even the timing of these discoveries magnifies their impact. Observing light from galaxies that existed less than 500 million years after the Big Bang is akin to peering at a newborn cosmos, capturing its earliest, most formative moments. Yet these galaxies appear almost fully grown, suggesting that the universe began producing complexity far earlier and faster than theory predicts. It is as if we are reading a book whose first chapters have been skipped, and the narrative is already in mid-story. The James Webb Telescope, with its unmatched sensitivity, is allowing us to turn pages that were once invisible, revealing a story of cosmic ambition, speed, and creativity that defies our comprehension. Some theorists even propose more radical possibilities. Could these galaxies hint at new physics, phenomena that have yet to be discovered, or dimensions of interaction that lie beyond the standard model? Perhaps the early universe contains forces or processes that we cannot yet replicate in simulations, mechanisms that enable rapid growth, structure formation, and stellar maturity in ways that our equations cannot predict. Each anomaly captured by Webb becomes not just a puzzle for astronomers, but a call to expand our theories, to consider that the universe may operate under rules more complex and nuanced than we ever imagined. And yet, amid these mysteries, there is an undeniable sense of awe. To witness galaxies that shouldn't exist is to glimpse the audacity of the cosmos, a defiance of expectation that reminds us how small our theories are in the face of reality. These observations challenge not only scientific models but human perception, urging us to embrace uncertainty, to question boldly, and to marvel at the elegance and ingenuity of the universe itself. If the wonder of these revelations excites you, subscribing ensures that you remain part of this journey, following the James Webb Telescope and the new frontiers it continues to reveal in the cosmos. As Webb continues its mission, it promises more surprises, deeper images, and the potential to uncover galaxies even earlier than those already observed. Each new image could upend assumptions, reveal hidden populations of massive early galaxies, and reshape our understanding of cosmic history. The universe, it seems, delights in challenging us, rewarding curiosity and punishing complacency. Each discovery is a reminder that the cosmos is alive with mystery, its earliest moments more dynamic and creative than we ever imagined, and that our pursuit of understanding is an ongoing dialogue with the universe itself. Finally, the cinematic vision emerges, billions of years of cosmic history compressed into faint glimmers of light, massive galaxies blazing with stars that should not yet exist, and the James Webb Telescope capturing these signals with astonishing clarity. Each image is a testament to the universe's ability to surprise, a challenge to human understanding, and an invitation to wonder. The galaxies that shouldn't exist are not just anomalies. They are beacons, guiding us toward deeper questions, greater knowledge, and the humbling realization that the cosmos is far more imaginative than our minds can contain. Subscribing allows you to continue witnessing this unfolding story, following each revelation as it reshapes our view of the universe, and discovering what mysteries lie just beyond our expectations. As we gaze deeper into these galaxies, we are compelled to confront a disquieting question. If the universe produced such massive structures so early, what else lies hidden in the cosmic dawn, waiting to overturn our understanding? Each discovery is a window into a past we thought we knew, revealing a universe more efficient, more ambitious, and more extraordinary than our models allow. Perhaps there are entire populations of early galaxies that remain unseen, faint glimmers beyond Webb's current sensitivity, each one carrying clues to processes that shape the cosmos in ways our equations cannot yet capture. The implications ripple outward. The early universe may have been a turbulent, almost chaotic environment where creation happened at breakneck speed, a realm where the ordinary rules of cosmic evolution were accelerated, twisted, and amplified. Some theorists have even begun to speculate on multiversal implications. Could these galaxies suggest that our universe is not typical, that other universes might follow different rules of structure formation, or that fundamental constants vary across cosmic domains? If galaxies that shouldn't exist are possible here, in our own universe, then perhaps they are common elsewhere, manifestations of universes operating under alternative laws. This line of thought stretches imagination to its limits. We may not simply be observers of one universe, but of a vast ensemble, where each cosmos is a laboratory of cosmic experimentation, producing structures that defy expectation in ways we can scarcely imagine. Subscribing allows you to follow the journey as these ideas develop, as observation meets theory, and as the mysteries of multiple universes unfold. Even within our own universe, the consequences are profound. Early, massive galaxies suggest that supermassive black holes, the engines powering quasars and shaping galaxy evolution, could also form far earlier than we predicted. If black holes of billions of solar masses existed when the universe was only a few 100 million years old, the mechanisms driving their growth must be extraordinary, potentially rewriting our understanding of gravity, accretion, and cosmic feedback. Each galaxy becomes a puzzle piece in a grand narrative, hinting at unseen forces, hidden processes, and laws of physics that are yet to be discovered. Observing them is like reading a cosmic detective story, where the clues are scattered across billions of light years, and the stakes are nothing less than the history of existence itself. And yet, amid the scientific awe, there is a philosophical resonance. To see galaxies that shouldn't exist is to confront the limits of human understanding, reminding us that the universe does not conform to expectation. It challenges the arrogance of certainty, the hubris of models, and the comfort of established timelines. We are invited to embrace uncertainty, to marvel at the extraordinary, and to recognize that the cosmos is infinitely more imaginative than our minds can contain. In a way, these galaxies are teachers, demonstrating that reality is richer, more complex, and more beautiful than we can predict, and that each revelation opens a new horizon of inquiry. If this sense of wonder moves you, subscribing ensures you continue on this journey, exploring each new discovery and following the universe's surprises wherever they lead. The cinematic vision is breathtaking. Ancient galaxies blazing with starlight across billions of years, captured in exquisite detail by the James Webb Telescope, forming structures that challenge every assumption. Spirals, dense cores, and luminous clusters shine in defiance of expectation, like cosmic paradoxes frozen in time. Each frame invites reflection, each observation evokes humility, and each discovery fuels curiosity. The universe is no longer a passive stage. It is a dynamic, creative force, capable of producing outcomes that our current science struggles to explain. The galaxies that shouldn't exist remind us that the cosmos is alive with mystery, endlessly inventive, and perpetually capable of astonishment. Looking forward, Webb's mission promises even more revelations. As it continues to probe deeper, we may uncover galaxies that predate those already discovered, structures that push the limits of what is physically plausible, and phenomena that force us to reconsider the very rules of cosmic evolution. Perhaps the universe's earliest chapters are far more intricate and unexpected than the simplified narratives we have constructed. Each new observation is a reminder that scientific exploration is a journey without finality, that each answer reveals further questions, and that the cosmos is a boundless theater of possibility. Subscribing ensures that you witness each unfolding chapter of this grand cosmic story, following the discoveries as they reshape our understanding of time, space, and existence itself. Ultimately, the James Webb Telescope has done more than see galaxies. It has illuminated the audacity of the cosmos, the elegance of creation, and the limits of human comprehension. Galaxies that shouldn't exist are not merely anomalies. They are invitations to imagine, to question, and to marvel at the universe's infinite creativity. Each light year of observation is a reminder that the universe is more astonishing than we imagined, and that our pursuit of knowledge is a journey into the unknown, where each discovery opens new frontiers, new paradoxes, and new realms of possibility. And as we stand in awe of these ancient, impossible galaxies, we are reminded that the act of observing, questioning, and imagining is itself a journey into the boundless wonder of existence.